Let me start the recording. Welcome everybody. Let me share the screen now. Oops, this was still off. Let me share the screen. And we are already recording. So I should share the desktop. You should see it soon. And we are up and running. So I'm gonna do a mix. I have some slides, but I also built a defense site and an attack site. And that I think is the most interesting part of the class. The slides are just for me, to remember to mention everything. So web security, welcome. Forms. Forms are these things we use in HTML to get user input when we don't use JavaScript and things like Vue, right? And so the attack is this. If I give you a plain vanilla form, you cannot be sure that the form has been generated by my website. So when I accept the form for changes, this could have come by people clicking on some submit button on some other website. And the problem is that these other websites could have hidden in the form some fields that correspond to what I am expecting on my site, and therefore trigger actions. And we will see exactly an example of this. And so the defense to this is to include in each form some secret code, okay, or token or verification token that checks that the form has been given out by our site, okay? So that when you get back the form submission, you know that it is a user who requested a form from you by visiting a page of your website and is not a forged form that occurs somewhere else on the web, okay? And so what I do is this. I explained it at the beginning of class, but I'm going to reenact it quickly, that if Joe comes and asks me for a form by visiting a page, I give to Joe a random string, and I write the same random string in Joe's session, so that when Joe submits the form later, I say, oh, this is Joe submitting a form. Let me go look up in his session whether I've written the key, the secret token associated with the form. And if I can find it, then I let Joe submit the form, okay? And one of the things that Web2Py does, I believe, I haven't looked deeply into it, but is that Joe's session, if Joe is using my site a lot, will become larger and larger, because one of the troubles is that you can go to a website and request very many forms, right, without ever submitting them. So there are all the extant secret tokens, and so Web2Py needs to do a little bit of cleanup in the session to eliminate all the form keys. I don't know what it does. I don't know whether it has a strict limit. I know that these form keys can swell up, and so Web2Py has one thing that in theory is very cute, but in practice doesn't work. That is, this user session. Sorry if I divagate a little bit, but this user session that you read from the database based on your cookie, right? Another place where to keep all this information is to encrypt it and to let users keep it in their cookie, so I don't have to store the session. That works really well. The problem is that sessions can become large. They can start to contain a lot of information, and the limit for all your cookies sent to a site is 4 kilobytes. And so, in practice, even with CodeGrader that does not have so many forms, I ran into trouble because these form keys were making the people's sessions swell enough that the encrypted cookie in the end was larger than 4 kilobytes. So, so that's one of the things. But so, this is the theory, okay? Let me now try to play with it in practice, okay? Let me try to put these things where I don't need to pay attention to them on the screen. And so I have two versions of Web2Py running. I have the defense version, and I have the attacker version, okay? I have them both running side to side. And one is hosted at 127.800, okay, start default index. So this is my defense version, okay. And then I have the attacker that is running at 127, but 8888. And there are an application called attack. And I'll give you the code of these applications, okay? So we will see how they work. Now I designed my defense application to start with a home page where I can just basically maintain a database. We'll see later what I put in the database to exemplify the attacks. But you see that there is a weak form that I can have in which I can add the data. For example, this weak form, oh, I'm sorry, I need to log in. Fine, let me log in before I can use these things. But this is what I call the weak form, okay? And I can add, for example, a potato, and the paragraph is like, potatoes are very important, but Romans didn't have them, okay? And I might have, 5 potatoes. And I add these, and you see now this is the data. So it's simply a form to add stuff. But if you look at the details of the form, if I go into weak form, and you care to do inspect, you will see that this is a super plain vanilla form. Okay, I have an h4 and an input, an h4 and a text area, and h4 an input and an input of type submit. Okay, I hope that this is visible enough. Hey, yeah. Okay, so there is no secret token nor anything. And in fact, if I go in the code, allow me to go in the code because I want to verify that I can actually navigate these things. So I have to be very careful because this is the normal site and this is the attack site. So let me go in the normal site. I have views and I have weak form. And the view for a weak form is simply this, right? There is no special defense. Now let's compare it with what I call the strong form. The strong form, I hate that this goes into a bullet, but the strong form looks like this. So looks very similar, but this is a form actually generated by Web2Py, which contains, in the form, also a secret token, okay? And the way this was generated is different. If I go into the code to look at this, you will notice that in the strong form, all I do is display a form. Right? I display a form that I produce in Python. So let me show you where these forms are processed, okay? They are processed into this controller that is called forms, okay? This is the processing. For a weak form, if the request is a post, I do the insert and I direct you to the index. If it's a strong form, the basic difference is this, right? That I generate a strong form via an SQL mechanism built into Web2Py. And so that is what causes it to contain. So, the problem of this class is that for most of the class you have things, you have seen things basically working. And so you may have been wondering whether I'm paranoid, right? So let's try to build an attack for this website, okay? How would it work? The way the attack works is this. So let me go to my attack site, okay? And let's look at forms, and this will create an attack for the weak form, okay? The attack looks like this. I'm sorry, I did not work to make the aesthetics pleasant. I'm sorry, I was kind of in a hurry. I thought this will take me 1 hour of winging it up. It ended up taking me 5 hours, if you can believe it, just because it was very confusing work with a lot of windows open all over the place. And, I mean, there's nothing conceptually very deep, but it took me much more than I thought. Maybe 5 is too much, maybe 4. But so I say, good day, sir or madam. At our store, we strive to satisfy our customers. Are you having a good day? No? And in the meantime, look here a moment when I go home. Here, I have these records, 1, 3, 6, 7. The last one is a potato, okay? So keep that in mind. Are you having a good day, sir? And so suppose you say yes. Okay, okay, and it did something kind of weird because it sent you to the other side, which is not expected. But you may be confused, okay? Or I may be able to do it better. And you say, hey, what the hell went on? Why am I on the other side? But what really matters is that here, if you refresh, we have now inserted a record in the other side. So these are 2 different sites. And by clicking a button on this side, I got something inserted in this side, okay? Now, how does this attack work? If you look at the code, it's actually very simple, and that's why I say it can be probably done better. maybe for the next edition of the class, I should work it to make it more believable. But the attack is done in this way. I'm sorry, it's the other app. And I need to go to attack week. So the attack week does something like this. I create a form, right? I'm having a good day, and then as I have form, action is equal to attack host. I mean, I simply wanted to be able to change one place only in my code to decide which where the target of the attack is in case I had to change configuration for the class. Okay, and so I give the URL of the week form to which to submit. This will be submitted as an encrypted data. The method is form, encoded, sorry. But the essential part is this. You see this div here. Here I'm putting something with display none. Display none means you don't see it, but not it doesn't exist. This gets submitted with a post, just like your form key does. And so what I did is really rather trivial. So I built a form in which I specify the title, the paragraph, and the quantity exactly as the other form does, right? And I just chose as target the other endpoint. And because the other endpoint doesn't check for the secret token, this goes through and that's the record, okay? So you can do it better, I completely agree. Mine is kind of bad in that, it will load the other page and stay there, okay? But, this might already be effective against a lot of people who don't really check why you're there. You may have many tabs open, you click on something, you end up on Facebook and you say, why am I on Facebook? You simply go back to where you were, and you don't think perhaps that a form has been submitted to Facebook that now makes public all your posts or something like that, and this could happen. In practice, the attack, I think, was used to add forwarding addresses to some of your web email clients, okay? So that, you would forward all your email to the attacker's site via a form post, okay? So now, if I also have an attack strong, which just attacks the strong form, right? And we can see how that works. If I try to attack in the same way the strong site, what happens is this. So I go to attack strong. It still asks me whether I'm having a nice day or not. And if I say yes, why did this happen? Okay, so what happened is this. If we go check the console, sorry, I should have made it a little bit bigger. Right, and there is this stupid overlap with this thing that I cannot get away with. Oh, goodness. But essentially, you see that there is a post to start forms strong form. It disappeared. So this is a choice by Web2Py. You could have changed it, right? But Web2Py, if you try to submit a form with the wrong token, it doesn't tell you go to hell. Instead, it tells you, hey, here is a blank form. Would you like to insert a record? Okay, that's their choice. Essentially, it's responding to a post instead of sending you away by just giving you a blank form. So that's what we see here. That it asks us to insert a record. And if we go to the other site, you see there is attacker title here that was the result of the attack on the weak site. But if we refresh this page, there is no extra record. So perhaps it's not ideal the way Web2Py does, because it does not highlight that an attempt to an attack has taken place. But at least the attacker actually cannot do anything, right? You could have navigated to that page where you can add data by yourself. So it's not per se a dangerous act to navigate to a page, but no change was caused in the database. So essentially the defense of the strong form worked, okay? So this is a sort of example number 1 of attack. Everything okay on attacking forms? Kind of cute, right? I mean, I could have hosted it on the cloud, but then I decided not to, essentially because I was worried that it would be too long in class if you asked me to change anything. But by the mechanism we saw last week, it would be quite easy to, we have 2 different Web2Py applications, and even if I have only one Google project like Luca Teaching, I could, you know, upload them, one to the version defense and the other one to the version attack, and they would work with different cookies because they would have there would be different hosts, right? And so I could play with it within the same project actually, and it would be kind of nice. Now, let me go on with the slides. I'm sorry. So this is forms. The other thing is API endpoints. So what is the possible attack? If you have an API endpoint, the API endpoint will accept some input. And so if I happen to be logged in your site, I can generate that input via some kind of post submission, form submission in one way or another. It may be difficult for some of these things, no, but it may be possible to craft, okay? Because it turns out that if you do, if you create a post on another site, again, you send it to my site along with the cookies of my site, if the format submits there. And so you can essentially fool with the same mechanism, okay? So you can look at it as a variation of the previous case. And so I built one, if you like to see it. Now, yeah, I don't know in the end if there is very much to see. I can maybe let you play with it. I just want to show you the code at least. So in the API, I have two endpoints. One is called insert record, which requires login, and the other one is called insert signed record, okay, which requires a signature in the URL that is used to be called. This is a famous API endpoints that require a signature, okay? And so this one, you may feel safe because it requires a login. Yeah? So requires login means that you know, together with the API call, I will get a cookie, okay? And I will check from your cookie that you are a logged in user. Okay, that is what auth requires login means. Okay, and in Web2Py, it has two different behaviors that are encoded in these decorators. And that, if you like, we could go read it and figure out how it works. Okay, but essentially the behavior is this. If this is a normal page request and you're not logged in, then I redirect you to the login screen. If this is an AJAX request, as I can see from a particular header that is set in the request that says I'm an AJAX request, XHR request, if you are not logged in, it's pointless that I redirect you, right? Because it's not really a page load, is an internal API call. And simply I give you a 403 that means access denied, okay? So that's an auth requires login. I simply check that you're logged in. Auth requires a signature means that I check that the URL is signed, okay? So the URL, when it is produced by the URL helper, has a signature added that is determined by hashing the URL and the secret token that belongs to your session. You have seen these signed URLs, right? They contain this signature at the end of them. That signature is composed in this way. What is your name, by the way, if I may? Sorry? Ismail. Yeah, it would be something like API add record, and then there would be a slash, and then I would look at Ismail's session, or your session actually. You would have something that is called, I forgot the exact name. I think it's called it's not called an auth key, but it's called a something key. Okay, but there is a key to form this signature. So it is assigned to you randomly when you log in. Okay, and so I take this key and I compute a hash signature that has as input the URL and that secret key. Okay, the outcome is going to be a character string that I use as signature. So when you try to access that URL again, I say, ha, this is Ismail. Let's look at his secret key. Okay, let's take the URL and the secret key, compute as a signature, and check that it matches with the signature you sent me. Okay? And the advantage of it is this, is that suppose I'm an attacker. I have this site that I just built called CrowdGrader, whose real purpose is, in fact, to steal your credentials from Facebook, okay? Suppose I try to do that, right? And but Facebook, suppose it uses the signed URLs for their API endpoints, right? Now, as author of CrowdGrader, I would have a problem to attacking you, because now I can look at how my Facebook works And so I can know which are the Facebook endpoints. Maybe there is a point, there is a Facebook API endpoint that says API get posts and whatever, no? So which I can get my own posts. But if I try to fool it so when you click on a CrowdGrader button, CrowdGrader can somehow get your posts. The problem is that even though I know the URL, I cannot guess the signature, right? Because the signature depends on your session. And even though you're accessing my website, I don't have your cookie for Facebook. And moreover, the key for the hashing is in Facebook servers. So even if I had your cookie, I mean, well, if I had your cookie, I could pretend to be you for Facebook, okay? Fine. But you see, I don't have the data in order to mimic it. Okay, so let's see, perhaps the example will clarify it, okay? So maybe I will go through the example after all. So how do I attack these API endpoints, okay? If I want to attack them, so this is how I attack the unsigned one, okay? I build a form that I will submit to that API endpoint. Basically, I'm essentially crafting a form that when I will submit it will have the right effect, okay? So let's try. And I can do it because I know that I can call start API insert record. I don't need to guess any signature here. Okay, so this will work. Let's give it a try. So when I'm here and I'm in, sorry, yes, I'm twice in the same site. That's why I'm confused. Okay. So this is the attack for the unsigned, okay? Which, I'm sorry, I was at a lack of fantasy, okay? I always ask you whether we are having a good day. But if I ask you whether we are a good day here, let's keep an eye here, okay? Here, the last record is record number 8, okay? And if once I say yes, this says okay, which is kind of a stupid reply because it's just what the API replied to me. But if you go here, you will see that now there is a row 9. Attacker title via the API, right? That I just inserted. And this is because essentially on another site, I can guess the endpoint of the API. And so I can craft something that can be sent there via post via your, along with your logged in cookie, because I do check that you're logged in. So that's a point of the interesting point of the attack. Now, if I try the same attack with against the signed endpoint, right? So this works in the same way. Let me show you the code a moment, but this looks exactly the same, except that that I'm attacking the endpoint that it says insert signed record. So by nose, this shouldn't work, right? Because we are requiring the URL to be signed. The problem is that here, as the author of the second site, I have no clue what the signature ought to be, right? I don't have the key associated with your session, right? And so this is the best I can do. I mean, or I could guess a signature, but then I might as well guess your Facebook cookie, you know? I mean, if I think that I'm, how is it called in English? Gladstone Gold Luck. That, you know, in Donald Duck comics, there is this duck that is really lucky. Gaston in Italian or French. Eh? Yeah, but it has a name. Goldilocks, I mean, Gladstone is the name. And then there is, anyway, ancient comic knowledge. So, but let me try then this attack. Okay, by nose, it shouldn't work. And if we try it in practice, I think I'm already here. If I say yes, this simply gets me a not authorized, right? Because we can look at what happened here, but essentially there was a post to insert signed record. The answer, unfortunately, is not written. I'm not logging the return error, the return code, but it would be a 403, and so it goes to this not authorized page that tells me that I cannot do that. Okay. So these are, you know, the exemplification of two of the main attacks against which we have been working in this class, right? And there is a subtlety to these attacks, and that is one naively may think, look, you know, there is your web page talking to the Facebook backend, for instance. But if you are an attacker, is it it must be hard to figure out exactly what messages you have to pass to the Facebook backend, right? So how can you craft an attack that works? And no, that's the point. It's not hard, because the problem is that you know, the API that Facebook gives to you is the same as the API Facebook gives to me, right? So I can essentially look at how my own browser communicates with Facebook or with a Gmail when I want to change my forwarding addresses, okay? And I can look at what it does then, and then I can craft with that knowledge an attack for other people. That's how it's done, right? So the problem is really that on the web, this is always perplexing at the beginning. And to me, it's even now perplexing because it's different from other things, right? If I give you, I don't know, a smart card, it's at least a little bit harder for you to decode, for example, what's going on in the smart card or in the SIM card of your phone. You cannot simply stare at it. Now, if you have money, you can do a lot of things. You can X-ray them. You can, you know, you can put them into a SIM card reader that you buy for a few $1 million, maybe, and you know, because all these things are sold by testing companies, right? So you can do that, but you know, the investment is non-zero. But in the web, is not that. If you're Google or Facebook or whatever else, or Instagram, and I serve you a web page, you have the web page. You can read it. It's JavaScript. It's generally obfuscated, but it's otherwise there, and you can trace all the network calls that go back and forth. And it may take a little bit of patience, but it's all accessible, right, for you to do the reverse engineering. And the problem is that Google and Facebook, hopefully, Google for sure, Facebook, hopefully, I guess. But they put a lot of effort in engineering their interaction so that it's secure, and also so that it's not completely obvious, you know, how you may tamper with it, even if you, I mean, it's not only secure, but also somewhat obfuscated. If you ever looked at the messages that go back and forth between Gmail and the base, you cannot really figure out all too easily what's going on, I guess. But there are a lot of very high value companies that are not done in that way, you know, that do an incredibly bad job of having a complicated interaction. You can basically read their JavaScript. So if they really forget one of the signature or authentications, they are open to attack, and they have been attacked all the time. Okay. Images. This is just advice I've already given you. So for site images, you can use static files. One thing to watch for images, or that I like to do, is that I don't like to give people the right to, I don't like to hand out to people a URL by which they can always and always and forever access the image. So this is, I say it for images, but it's true in general. You want to have always revocation abilities to access. Right, so you never want to give out a URL such that if I decide that you should not have access to that image or to that piece of content anymore, now I have no recourse because I actually gave you the static URL of the object. So, sorry, I got the hiccups. I'm a security attack for sure. No, I'm just kidding. But so you should always give something that enables you one level of checking. Maybe you should actually give the name of the image, but then you check the permissions once you get the request. You can complain that's expensive because it requires a database access, okay? And that is true. So if you want to avoid doing that, maybe give a signature that is somehow cryptographically computed out of the image name and of a current time that is part of the image URL. In that way, when you get the request, you can check that is signed for the correct time, and you can make it valid for 1 hour, and otherwise you can ask for a reauthorization, right? You see the point? Sorry, maybe I'm going too fast, but the problem is this. Anytime you check for access permissions, if you do it properly, you need some kind of database access, right? Because you're asking me for an image, suppose, and you may ask me for the image, and you may be called Helen, and now I check, you know, Helen, let's see, when time does her access expire? Okay, valid, okay? But by doing that, I've done some database access, and I've lost some milliseconds. Maybe not maybe, but maybe 20, 30 milliseconds, and this puts load on my database. You may not want to do that if people are loading images all the time. And maybe one strategy would be this. The first time Helen asks me for that image, I go and say, yeah, Helen really can look at that image. So let me compute a URL that says image name, Helen, 5 p.m. today, and a cryptographic signature that I compute with a key. And I give her this URL. Next time she asks for that URL, I don't need to do any database access. This is one advantage of signatures. Signatures, unless you need to read your signing key from the database, signatures can be checked by in memory by just recomputing the hash. So I can, when she asks me again for that image, I can say, Helen, she has the image name and the expiration date, and actually the signature matches. So, you know, this means I gave her this URL. She could not have possibly invented it. So if she asks me with that URL, I honor her request. And you can do better, because if instead she asks for that URL and the deadline is expired, because poor Helen may not care to know for how long I sent the URL and she just hit reload on the page, whatever, right? Then instead of being nasty to her, you can say, Helen, this is the image name. The hash doesn't quite, the hash computes, but the timestamp is expired. Let me not boot her out, and let me rather go back to the database and pay the penalty that time, and you know, and really check her access, and also, by the way, give her an updated URL that will work for next time. No, you can do that. But this has two advantages. First of all, is that you spend the CPU and database access only once in n hours. You can decide what the n hours are, maybe 24 hours, maybe 1 hour, depends on how paranoid you are, okay? And the other advantage is that if you change access privileges of Helen, all her URLs will stop working at some point. No, so you still retain the ability of booting people out while avoiding really checking every single one of their accesses. Okay, so that's something that I think is, is both often done and very useful to do. It's a bit the principle that I showed you with the signed URLs for Google Cloud Storage. I mean, it's exactly like we do in my startup Cameo, right? You can have access to some images of webcams, but you can grant access to your friends or spouses or children or whatever else you may ever wish, right? So suppose you have access to my webcam images. It's great, but one of the things with webcam images is that you have a whole stream of them, kind of like an Instagram stream, you know, because you can scroll back and forth in time. And you have a gazillion of them. And you don't want to do a database access to check every single one of them that actually, you know, you have the right to see that image, because it could get old really pretty fast, no? So what we do is something more similar to this. We use some hashing technique to check, yes, you have access, and then maybe we renew it once an hour, no? So if you boot me out of your account, I may still be for 1 hour able to see something. And that may sound bad, but you know, it may not be that incredibly bad, because in any case, I may have it cached on the browser. Actually, I don't know it's 1 hour. I have to say somebody else did that part. I only know that there is a hashing. But it's certainly much better, right? So the other thing you have to know is that, I mean, with images, what you give out is already given out. You know, there is no, I mean, I'm sure you know better than me if you use Snapchat. You know, even if the things auto-destroy or you lose access, people can always take screenshots. And so once the information is out, is out. But at least you want to check that the permission to renew the access or you know, continue to access is expired, essentially. That's the best you can do. Okay? Questions so far? And now for a big change of topic, databases. So I think many of you have seen this comic, XKCD. And I think this is the best way there is to explain the vulnerability. Okay. So the idea is this, that if you, in Web2.5, I've taught you essentially to talk to the database via this database abstraction layer. But there are people, especially in the good old times of PHP, I think, but there are people always that think that they want to do something special. And I've done it at times too, when I wanted to do something special, except I really had a good reason, unlike others, right? So, but there have been times where you say, okay, let me write raw SQL for one reason or another. And so you need to sort of piece together pieces that are due to your SQL input and pieces that are due to the user input. So for example, I do it in the next slide. Imagine that you write db execute SQL, insert my table name class values plus request vars name. So I'm splicing together a piece of the SQL syntax up to this quote. Then I'm splicing the name of the student. Okay, oops, sorry. Then I'm closing the quote. Yeah, right. So here it's all wrong actually. Yeah, I also get into quoting problems. This should be single quotes, okay? So that you start the quotes, and then these quotes should be in single quotes. Happiness, right? And then actually, these should be in single quotes up to here, and then you know, then there should be this piece here. Okay, now it's correct. Okay, so essentially, I'm trying to obtain insert my table name class values, and then I need these I need this open quote, and then you would imagine like Luca. Then there would be a double quote to close the Luca. I mean, maybe it's easier to say what I want to obtain here is I want to say insert my table name class values. It works with every case, but traditionally people use capital like Luca CMPS 183, no? So that's what you really want to say. I think this is not needed. But this is really what you want to give to the database. So the fact is this, the database talks, it's surprising at first, that the database talks to your application via an internet connection. Okay, the database is typically sitting some other place, and so you have a database server and you're talking to it. And to me, it reminds me very much, you know, in vessels of the Navy, that there is, you know, this funnel, and you say, hey, steam all ahead, and these people down in the machine room, no? So you essentially need to serialize your orders into some string that says what you want to do, and then this string goes down to the database server. Yeah, it looks weird, right? But it's this way. And then the database server responds you back with another big string that says yada, 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 and you have to parse it and use it for your data, okay? So this is the string that you need to pipe down to the database server for it to do the insertion, okay? And so here, what you're doing is that you're gluing it together yourself, okay? And these triggers one of the 3 great ways of breaking computer science stuff. So in general, I mean, aside from the web, but more in general, there are 3 ways in which misfortune happens, right? And there have been with us for decades at this point. One of them is buffer overflow, okay? So people decide, oh, I allocate 200 bytes for this in a language like C, and you know, people write 250 bytes, the other 50 bytes overwrite in a prescribed way some more code that you thought would not be overwritten, and they get in that way. Another way is, another of the primary ways is quotation. Or how do they call it? Yeah, quote. I mean, quoting and unquoting and sanitation of these. So it often in computer science, you have a language that has to include the snippets of another, right? So here we are writing in Python above, but we have to include the snippets of another language. And so we have this problem of the quotations and the unquotations. So this bag of the previous slide is based on exactly these quotation problems. So that are one of the biggest sources of, you know, of attacks possible. See, when he says, did you really name your son Robert drop table student? So this Robert quote, actually, I think I'm wrong here. I should have flipped the double quotes and single quotes. Help me. Okay, so I think it should have been this way. I'm sorry, you see, these should have been double quotes, and that should have been a single quote, actually, to make the example work. Maybe let me do it this way, right? Plus, and so, I'm sorry, the plus, then I'm adding I'm adding comma, close, comma, close. Okay. And here now I wanna close these, then put these, and okay. I think that this would be essentially correct. Okay, so when you put the name of the student here, okay, the name of the student will close this quote. Okay, so what SQL will see is insert in my table values name of the student, and then it will see that this closes that particular request. Okay, this will close that particular request. There is a semicolon, which is a request separator, and the next command follows, which is drop table students. Okay, so this is based on quoting. My old joke, and you know, I hope it doesn't get too much around, but you know, people who did the bash shell and these computer shells, which I always thought were marvels of complication to use. You know, I thought that thank goodness there are not 4 types of quotes. Otherwise, you know, you wonder what they would have done with quotes. You know that there is single quote that behaves in a way, double quote that behaves in another way, a backward quote which is still different. You would imagine if they had invented a 4th type of quote, we would dive out of the window, right? But so essentially, quoting and escaping is one of the main ways in which software can have vulnerabilities. The problem is always the same. The problem is including in a language pieces of another and doing it by hand. Okay, and this opens the door to this. This is called an SQL injection attack, but there are other attacks that are very similar to these. We will see them later, that are again caused by the same vulnerability of the quoting. Right, so there is a buffer overflow, quoting, and what is the third way? I had it in mind and then I forgot it. What is the third way to generate in which you always break software? Well, okay. No, later. So what is the cure to SQL injection attacks? So, I mean, first of all, why do they care? Do you care about them? Not because they drop tables. That would be kind of bad, but not too terrible, because typically databases have daily backups. So that's one of the reasons I always claim never host your own database. You know, use a cloud service. Like if you do it on Google or Amazon, you click a button and you say, hey, yeah, please do daily backups and store them for 8 days and distribute them geographically so that I don't lose everything, right? It becomes very easy. If you have to do yourself database replication, you know, it's not that easy to configure. So, you know, my strong advice is, unless you're a database expert, don't actually manage your own database. But the problem is not that. You know, the problem is that a real query would do something else. I would register a login with a system called Luca, no? And I would have like, Luca del Faro is taking CSA 183, and I do a homework 1 in which the professor gives me as feedback, you are a great student. Great. At that point, I want to steal your data. And so I would inject a query that says, for student named, I'm afraid I don't know your name, but I assume it's Bob, okay? For student named Bob, read the list of secret passwords and update the Luca homework 1 assignment feedback to be that list of passwords, right? So what you do is essentially you use these attacks because you cannot directly cause information to be extracted and printed out, typically, right? You are basically inserting some student name. You cannot typically immediately fish out the defect and say, oh, here is the candy. But you can cause essentially the information to flow to records to which you have access, and then you can fish it out of there. And then you can automate the attack, right? Because you can use things like, oh goodness, I forgot the name, but this web automation framework, oh boy, the crazy thing is that I use it. Selenium, yeah, you can use Selenium to program it to do and every time you do an attack and you fish a bit out of it. You do an attack and you fish a bit out of it. You do an attack and by the end you have fished out a lot. I mean, many attacks, I think that, I don't want to misspeak, but I kind of believe that the attack to target the store was done via SQL injection. And you can look at the famous attacks by SQL injection, and there are plenty of them. Some of them hundreds of millions of dollars in liability. Okay, so that's another category, and that's why, you know, I essentially ask students, you know, unless you truly know what you're doing, use a database abstraction layer. Never write raw SQL code. JavaScript insertion attacks. These are kind of fun because we can get them to try them more easily than SQL injection attacks, I guess. No, it's not true. It's simply yesterday I chickened out of the fact of writing a MySQL injection, a place where to have the injection. But I wrote for you a place where to do the JavaScript injection. So the point is this: assume that instead of calling the student drop tables in that way, I call the student open script tag, do something crazy, close the script tag. No? Now the student is called that way, right? I mean, I could call the student in a way. Let me just go through it a moment with you. Imagine that I call the student, I call it script alert. You are an idiot. I don't know why it's so nice to insult people, especially when I'm insulting myself, basically. Okay, but script. Okay, so imagine that this is my name. I put it in like this. What happens when the name is displayed? Well, if you go naively, you say, well, this is my name. These characters will be taken and spliced in the web page. Now, do you know what would happen if that was the case? That you would see as something that flashes on the screen that says you are an idiot. Okay, and in fact, we will have it happen, okay? Because the point is that when you add stuff to a web page, it's immediately interpreted by the browser. I think I went over this already when you set the URL for an image, right? When you write the URL to an image, the browser is saying, oh my goodness, now I have a URL, let me get the image and display it to you. And here it's a bit of the same, right? If you insert a bit of JavaScript in the page. So how comes people are not crashing every possible code by including things like these in their names? No? How does it work? And the fact is that you may not have paid attention, but in Web2Py, these are meant to be the safe delimiters, okay? And in Vue, these are the safe delimiters. What does safe mean? Safe means that somebody has taken the pain of going through every string you actually post on a site via Web2Py and via Vue and do the following. They take the script and they replace smaller than the open tag with ampersand lower than semicolon, right? This is an escape sequence that is displayed as smaller than, but is not interpreted as the beginning of a JavaScript tag. Okay, and they replace every greater than with its corresponding escape sequence. By doing this replacement, what you see on the screen is still script, you are an idiot, close the script, but it's not interpreted. So you need to do, again, this escaping and re-escaping. And as you can imagine, this belongs to category number 2 of the ways of shooting you in your foot with computer science, right? Because again, if you get that escaping routine wrong, you are in deep trouble. And the fact is this, that the people like Massimo Di Piero, when they write Web2Py, they wrote that escaping routine once. Then they had their eyes, the eyes of many other developers. There were security experts from Berkeley that actually looked at Web2Py code and, you know, mostly okayed it, pointed at a couple of vulnerabilities. But these well-known frameworks have a lot of eyes on them of people who are really quite expert, okay? And so they are fairly vetted. If instead you start sprinkling your application with your own escaping rules, chances are that at least in some place you get it wrong and people exploit it. So let's see how it could be exploited. In order to exploit it, I had to go a little bit out of what we do normally in Web2Py. Because if you continue to use the safe Web2Py, I could have done it a couple of ways, you know. One of the ways is that Web2Py has special brackets that are not open bracket and open bracket, I think, but I'm not quite sure because I almost never use them. But I think that the unsafe ones in Web2Py are these, okay? And I cannot swear on it because I use them so rarely that I might be wrong, but I think it's documented somewhere. Rather, what I decided to do was another thing. So I wrote my code in this way. Let me show it to you because it's kind of fun, okay? So I add a record that says like, this is a simple attack, okay? And here I really write script alert, okay? You are an idiot because I promised, so I have to write this, right? And so I close the script tag. And how many idiots there are? One, okay? So I insert these and, you know, nothing happens. Because if I view this record, okay, you see, this is printed out for me. But if I inspect these, unfortunately, it's very hard to inspect these. Because if I inspect these, where is it? You see, this character here, the browser, unfortunately, believing that it's doing me a favor, it's displaying it as an angle bracket. I know it's not an angle bracket. And I think that if you do view and you say, no, file, view page source, where is it? Okay, view source. Okay, if I look at the source code for that page, you see, okay, it's here. You are an idiot. You see that the lower than, greater than, etc., they have been converted in their characters, right? So you have to go into this view to actually notice the replacement. Okay. Now let's assume that I've been kind of sloppy and I wrote my own web page that works in another fashion. And so let me assume that here I wrote this particular way of being attacked. So wait. No, let me look here. Injection delayed, actually. This is the interesting part. So sorry, let me show you how it works. Sorry, that's why I spent so much time, because it's sort of so let me go to injection. Come on. Okay, let me use these wide. Sorry, there is something wrong. Okay, delayed injection, okay? So type here the record ID. I have to type here the record ID of some record I want to attack. So like I want to attack record number 10, okay? So I write 10. And let me show you the code before I do it. So what I do it in injection delayed is this. I use vo and I wrote the following code. Okay, here I say type here the record ID, and then when you type in the record ID, I call this function that is called get record. Okay, and then I have a paragraph with to hold the record title and a paragraph to hold the record paragraph. Okay. So essentially what I want to do is this. When I say record 10, I want to be able to read the record and display it on the screen. I made the placeholders for where the title and the content will go. And now I want to make it appear in JavaScript, okay? And my JavaScript code does the following. When I say get record, it uses a get JSON API, you know, to read my record. I think I won't show you the code, but this is run-of-the-mill code we have written gazillion times ourselves, right? But then I do another thing. Instead of displaying the record myself using the normal foo helpers that I've taught you, right? That you use $open brace, then you say the variable close brace. I use jQuery and I use its HTML facility. So this means, hey, please get the element that has ID record title, which is this, right? This paragraph element will be retrieved, right? So get that HTML element and inject into it this HTML. And so I get the title. That's a way, commonly used way for me to add the content inside, inside the DOM tree, right? I mean, Vue came and with Vue, many other frameworks, and so it sort of revolutionized how you would build web pages. But once upon a time, you build web pages by saying, hey, you know, get this element and put this text inside the element. And the problem of doing it this way, by the way, is that I'm not quoting it, quoting the text. I'm not safely substituting the open tags and the close tags with their escape sequences, right? So now when I ask for record 10 to be retrieved, suddenly the script tags will be put inside and the web browser will interpret them. So if I say now show, this says that I'm an idiot. Now you think that this may be you know, a trivial thing to do. But you can do much better, right? Because let me see if I actually, so I have a much more interesting attack, and with that I will close. You know, we began late. I think there is nobody after, no, there may be people after us. But so I built an attack that is more sophisticated. Let's look at it. So this is a more like a real attack. Okay, and I will play it to you now. So this does a get JSON. So, you know, in a script, I can put what I want. And the idea is this. Once I am in a script running in your page, I have access to your page. I can go look at stuff in your page and send it to somebody else via an API call. And you may think, oh, but you don't have the cookies for the API. No, because I can build a receiving site that does not ask for authentication or anything complicated. It's just like a vessel for received stolen information. So I can put, hi, my name is Luca. I really like to meet you, you know, in my blog post. And then I can put this code that says, oh, you know, take your access to your username, your email, the text that is on the page you are currently looking at, which may contain other pieces that I should have no access to, your list of friends, your whatever else. Package it nicely and send it to me. Right? That's a completely plausible attack. And in fact, it's used. This is called cross-site scripting. And so in this cross-site scripting attack, what I do is simply this. I say get JSON, I go to the attack site, and I have a receive user email, and I'm passing it a payload of stolen email is equal to the user email. Right? Because I can examine, by the way, you know, imagine that I want to steal your information out of Facebook. I have a Facebook page as well. So if I look at my page, I know that my user email is contained in a particular JavaScript variable and my post list is another JavaScript variable. I have everything in front of me already. So it's quite easy for me to say via cross-site scripting, you know, this is the information you should send to this API endpoint, no? And so I'm going to do that. And so this is record ID number 1. And so when I retrieve the record ID number 1, okay, this simply says my title. I'm completely clueless, you know. This seems to have been, you know, fine. I see the right thing. And this is because, you know, the content was my title and only then the script began, right? So I can see something entirely plausible and completely clueless. But if I now go to the attacker site, to the home site, okay, so this is the one I just got. No, wait. No, sorry, this is not the attacker site, it's the other site. Yeah, sorry. I want to go to 888 attack default index. If I go here, okay, so these are the stolen emails. I did stole one for myself yesterday while developing this website, and I stole one more today, you know, now in front of you. I mean, I don't have a date stamp. I should have put it, but this is the second one. In fact, let me repeat it, right? So if I click show again here, oh, maybe it will not accept me clicking twice. Let me reload and click one and show. But if I do this again, no, then I can go to my attack site, I can reload, and oh, actually it worked even before, yeah? So I can go there and steal it once more by clicking on show. I can go here, and now I stole the email 5 times. And you know, stealing the email, I decided to do it just because it was quick. But really, you can steal whatever else is available in JavaScript on that page, and not only in JavaScript, because you have a way via jQuery to get the content of any HTML tag, right? There is a way, I haven't shown you, but it's called, you see, I can tell you what it is. When you call HTML with a value like this, you are saying, please put these as the HTML content of the tag. If you call HTML with an empty argument, not even an empty string, but just open close parentheses, what this does is returns to you all the HTML inside that element. So I could call that on the top element of that page, and I can ship all the page you are staring at to somebody else. Okay, so that's an obvious attack. Okay, so the other morale is always look at sanitizing the input. I mean, whatever you put on a website. You have been immune to these because you have been using either Web2Py or Vue, but otherwise this is a prime avenue, and it's called cross-site scripting. Okay, I think I'm 3 minutes over time, so I need to stop the recording. But so on Friday there is going to be one project presentation, and otherwise I will you know, close the loop on these. But it may be a shorter than usual class. There is still a couple of things I want to say about security, and then I can actually answer any questions on hosting. Okay.